This course in the LabVIEW have the 5 steps, more or overview as like we try to develop the measurement system. We try to acquire the data, how to acquire the data using LabVIEW. And then we try the next step is like how we can control the instruments using LabVIEW. And only that is not done. Like if we only acquire the data and we see on the screen, but if we cannot store it, then it's no use, right? So there is this step, it's called data logging. Data logging means it is a term for saving the data into your hard disk. Okay, so yeah, we know like in Word document we can save the data like by clicking the save. But for instrument to save data, long data, big data, we need to have to do some processing, right? So this LabVIEW has a very good another technique so that you can do it automatically, like many times at the same time, many files at the same time. And the last one, it's called like we acquire the data, we control the instrument, then we save it data. But if we cannot present it, like if we cannot make a report of it, it's no use, right? So lastly, we learn about how to report generate automatically, create a report of saved data. So this is actually sequence of this we what we are trying to learn, right? So first we make some application which can like do what we want to do, then try to acquire the data. Then once we try to acquire the data, we try to control the instruments according to data. Means how data is collected, based on that data, we decide that which instrument should start or which instrument should work now or we should stop now. So that is the process. And then once we do all these three, we try to log the data. Means we try to save the data or we know what is happening and we make a file so that anybody else who is trying to use the data, he can know what happened before. So that is called measurements. And once it is done, then we do its analysis and then report generation. Okay. So these things you can learn from that course, what is in that book. Okay. So if you learn that book from first to end, you will get to do these things, right? But this is just initial and basics. Okay. Based on this, you can again, based on your interest, you can go further and you can develop various techniques. Like there are very complex techniques there, but for those to you to understand those, you have to have this basic concept clear in your mind. So that's why we are trying to learn basics, and then you can whatever your imagination, you can try to learn from that. Okay. So to know the LabVIEW or know the programming in LabVIEW, you need to have something basic prerequisite, like for example, you should have some idea about how this OS is working. Okay, so all of you know the how Windows is working or Mac is working, and then you need to have you should know something about writing algorithm or something called flowchart or program. So this is what we will try to learn in this, and then and for that, what you need is already you have. So, like the how OSs works, and how how to write algorithm or like stepped sequences, right? So that's the basic things. Everybody has that. Steps. Okay, so LabVIEW is what? LabVIEW is a short form, right? You know this? What is LabVIEW? Yes? No? Yeah.
Okay,
So LabVIEW is a short form of
now
Laboratory Virtual Instrument Engineering Workbench. Right? So LabVIEW is a short form of that, right? So you can see what it means in his name only. So this is one kind of software which can make virtual instrument for engineering, okay, for laboratories, right? So that's why it's a LabVIEW. Okay? So you have the capability to make virtual instruments for engineering, which can be used in various laboratories or industries using this software. So that's why it is very technically correct name is given is like is LabVIEW. Okay. So it is a one kind of programming environment where you can try to make different programs And as I told you earlier, like it is a graphical notation, means it do by drawing, not by writing anything. So this is its a plus point, because of this drawing kind of nature of its programming, you can you don't need to have to know that what kind of logic is there when you design the program, but you can see itself like how it is there. So after seeing, means you know how the steps or algorithm works, then only seeing the LabVIEW you can know that what is the program is about. So that's very easy to understand for anybody. Means if Kong develops some program and then she get to see what is that program, then he, without asking Kong, he can know that what is inside that program. It is so graphical, so it is visually you can understand what is it is. And it is designed for like people like scientist and engineer, because these are people which try to do new things all the time. So already whatever the programs or softwares are there which are limited, and the scientists or engineering develop new things, and for that they need to have new softwares. So this LabVIEW provides easy path to those people, and they can create very complex programming using this LabVIEW. So it is meant for them. So it is now used everywhere right now, means for development purposes. Okay, and sometimes it is called graphical language, G language. Okay, G language. It's called G because of graphical nature. Sometimes, but it is not a correct way of calling G language. It is, we call it only LabVIEW, right? And LabVIEW, because it's intuitive or graphical nature, you can do it very just drop and drag and drop some things on your programs, and you can make it work, that program, and you don't need to know what is behind that. You only see what I'm doing, and then you are able to do that thing actually. So it's very easy to write a program in LabVIEW. So if you compare this program and with other languages, for example, C or Visual Basic or Visual C, this LabVIEW can make the same things in a few hours, which are required like few weeks to do in other languages. So that's why it's so powerful, and you can like once you master, you can do like I think of one question and I can do it in 15 minutes what I want to do. So I will show you some example when we go through this presentation. We will create some example and we will try to means we just imagine what we can do, and we can do it on your LabVIEW Pro. Okay. So yeah, the LabVIEW instruments means as I mentioned, the LabVIEW is the full form is virtual instruments inside that. Okay. So it is kind of software only. So it is only codes, but it act as a instrument. Okay. So I will in next slide I will show you what is the instrument and how it is related to the LabVIEW. Okay. So the software based instruments you create using LabVIEW. Okay. So and these programs of LabVIEW is called virtual instruments. What do you call it? Virtual instruments. So it behaves like some kind of instrument, but it is not a real instrument, right? It is on your PC, so it is virtual. So we call it virtual instrument, right? And this due to graphical nature, I mean, as I mentioned, like so if Kong developed some programs and he gave it to she, then he don't need to ask Kong what is the program, but he until just she see the program and he can see, yeah, what is he is doing. So it is such a easy to understand. So it is called a data inherently data presentation package. So you can, instead of telling what I'm doing, you just give this LabVIEW program as a picture, and the other peoples will know what you're trying to do. Okay, so it's as easy to
Okay.
understand too, like that. So and now they, for example, LabVIEW is how it is very important in many industries, like it is used for engineering, process control, biology, chemistry, physics, etc. It's everywhere it is. So this is what LabVIEW can do it for us. For us. So it is only you which you can imagine what problems are and how you can solve. And LabVIEW is very useful for that. Okay? So I told you I will show you what instrument. Okay. So if you see any instrument in your real life, for example, here I showed you, this is called, what is called? Keysight digital multimeter, okay? So it is kind of multimeter instrument, not day-to-day real your life multimeter, like the yellow kind of multimeter, but this is a scientific instrument which is used for measuring the current, voltage, and capacitance, etc. And this is the instrument, okay? It is available in different laboratories, right? Do you understand what I'm
Mm.
trying to say? This is instrument, right? This is real
Yeah,
instrument,
right,
okay? It is a picture from the internet, right? So this is the
right.
instrument, and what are their parts? Like you see, the first part you can see from your instrument is like front face, okay, where you can see some digits, some buttons, some probe point to connect, etc., etc. So this is called front panel, okay, of real instrument. So this is front panel, okay. So in front panel, usually on real instruments, there are like buttons, some indicators. Indicators means like digits, okay. You see digits, that's called
Yeah,
indicators, right? And buttons to change its functionalities, and there are some connector for or what we call other things to connect at the top here. So these are some connectors to connect to measure the current or voltage. You connect here. Then what is the next part in a real instrument? Like if you open that instrument, you will see some circuits inside, right? And then
mm,
what else is there? There is a back panel. Okay, this is back panel. It is front side here, and this is back side here. Okay, so here you have some connection to connect to your PC or some connect to the another instruments like that. So, okay, so this is called back panel, or it's called connector and back panel. So you can apply the power and you can make it connect to the PC. Okay, so this is a real instrument, and there are three parts, like front panels, inside circuits, and back panel. Okay, where you can connect to others. So how it is related to the LabVIEW means, as I mentioned already earlier, that instruments are like virtual instruments and real instruments are similar kind of things. So if I use this analogy like front panel circuits and connector panels into the LabVIEW, how it looks like, it certainly look like this. Okay, so you see the front panel will be like this, means when we develop in LabVIEW, we have three parts to develop. First is front panel. Okay, so we try to develop a front panel where you can know what to put on front panel. For example, I want to ask user to enter some data. I will put here, enter some value. Okay, and then there is a after entering some data in front panel, I will also present some values back to user. Like you enter this data, and I will give you it's a square. Okay, so entering data or outputting data is done on front panel. Okay, and this is called block diagram. So whatever you want to do some calculation on for this front panel, you have to do programming on these block diagrams. Okay, so you design everything whatever you want to do, means whatever calculation you want to do is onto this. And this is the third one. It's called icon or connector pan. Okay, so I will explain it later. It has many things to do. Okay, so
mm,
here on, yes, any questions? Yeah, no. Uh, so this is called user interface. Okay, this front panel is user interface where you can put like inputs. Okay, means like I want to ask somebody to enter some X value. Okay, so that is called input, right? And then we present it as output, like means after some calculation, if we have some value to give it back to user, we give it as output. Okay, and in LabVIEW it is called indicators. Okay, and third one is information for user, means like we write some text and say that, yeah, so this is this value is for this, and after giving me this value I will give you the output of that. Okay, so that is front panel. Okay, so front panel has three kinds of information onto that. So when you design, when you design the front panel, you try to put this kind of things. Am I going fast? Like I don't know what I am talking, right? You can ask me, okay, anytime, because I know it's very. That's why I ask, like, did you read that book or no? Yeah. If you don't worry. We will do it right now. Okay. So it is just to give idea what is on that. Okay. So this is called front panel, where we put three things on top of that. It is called inputs, outputs, and information for user, like some text. Okay. And this is a block diagram, and this has three parts inside that. Okay. I will show you all on my LabVIEW, so you don't need to worry about that. Right. Okay. So this is the block diagram. Okay, this white thing where we draw many things, and this is called block diagram. And where in that block diagram there are three types of things: nodes, terminals, and wires. Okay, so there are three things. I will show you what I am trying to say. Okay, so just remember that there are three things here in block diagram. There are three things in front panel. And icon and connector, it will be coming in next chapter. Okay, so these three things in front panel, three things in block diagrams are very basics, and we try to know what are the difference or details inside that. Okay, now I will show you what is a LabVIEW. Okay, I will try to open my LabVIEW, and then I will show you how you can do that thing what I showed you earlier. So where we develop program is this one, LabVIEW thing, right? LabVIEW software is there. And using this, you create different things. So nowadays, there is a tendency to make a project directly, not a single virtual instrument. Means if you want to make some applications using LabVIEW, you don't make one file. Okay, you make a lot of files, and you try to put it together to make a big applications, right? So for that, to how to like have everything what you call collected properly, so that we know that this file is here, this file is here. So for that, LabVIEW has a called element called Project Explorer. Okay. So when you start here LabVIEW, okay, and you create a blank project, it starts like this. Okay, this is called Project Explorer. Okay, so I will show you. I will show you on my LabVIEW. Okay, so don't need to do that now. So when you do this Project Explorer has different parts in the LabVIEW. Okay? This part. So this is where you create your VI. What is called VI means virtual instruments. Okay, so virtual instruments, in short, we call it VI. Okay, so we create VIs by right click onto this my computer icon, and then click on new, and click on this virtual instrument. Okay, VI. Okay, so when we click, new window will open, and it will say that it is a new VI for you. Okay. So okay, so I go now to LabVIEW now. Okay, I will show you on a LabVIEW. Okay, I will start sharing the LabVIEW screen.
Right.
Yeah. So we create a project using blank project here, right? So when we right click on it, and then we go here. Okay, are you doing it?
Yes.
Yeah. So this is called before doing this. Okay, before doing this, how about saving this one? Okay, so we create one project. Okay, then we click on here. Okay, this is called save project. Okay, when you save a project, I don't know, you will see my screen. So I save on. I give a folder name. You see my folder anyway. I will. So we create one folder where you want to save it. Okay. For example, if I want a project, like for example, we are doing chapter 2, I just give a project name as chapter 2, okay, and then we create a folder, right? And then we give a project name for folder. Project name for that project. This LVPO PROJ file is LabVIEW project file. Okay, so we give a name for that called now it is chapter 2. So chapter 2 is that. Okay. So this is a project file which has the information that how the file structure is there in your project right now. Okay. So you see my project name is changed now to chapter 2. Okay. You see it here?
Yeah.
Yes. Now we start, means whatever I save, it will be saved under this project name. Okay. When I open project file, I will open all the things together. So that's why it is very important to make project file. When I do, I will try to share my whole screen so you can see what is going on. Okay. So right now, what you are seeing is called a front panel. Okay. This is square things or front panel, right? And there is another window opens. It's block diagram, right? So as I mentioned on screen previously slides, there are two opens windows. One is called front panel and one is a block diagram. Okay. So on front panel, you try to design what you want to show the users what should be there. Okay. And on a block diagram, you try to make programs so that user don't have to worry about what is inside the block diagram. Only he will be seeing what is on front panel. Okay. Only programmers like you and me will see the block diagram who develops and share to each other. But on front panel, you try to make only inputs and outputs onto that screen. Okay. Yes. So I will keep it open like this, and we will go to the next section. Understood, like when you start a project, we can make one project explorer file, okay, which you can save in one folder, and all the VIs you create, it is all related to that project explorer now. Okay, so when you open that project file of LabVIEW, you know what are the things inside that LabVIEW project. So you don't need to find like where I saved that one VI and which is included into this project, but it is not at the same place. So it will keep a track of that. Okay. So we go to the next thing. Okay. So now we as we open the file, we know there are two files open, right? One is block diagram and one is front panel, right? So on front panel, as I mentioned before, we use controls and indicators to put on that screens. Okay. And on the block diagram, we use functions or something called, like, you see here, there are some functions you can put on the block diagrams, right? So this is all coding, right? And this is only to mention like enter some value here, enter some value here, and it is done using this kind of tool palettes. Okay. Using this, you can put it here, right? Yes. Any doubts? Maybe there are some, like, the icons or the blocks will be some different types for you and me, because I did some other settings, right? I will tell you how to do that also. So there are two things. One is control palette, and there is another thing is called function palette. Okay. So the function palette is only available when you work on block diagram. Okay. When you try to right click on block diagram, you see this function palette. When you right click on front panel, you see the control palettes. Okay. So there are two palettes which are both only related to their respective panels. For front panel, you get control palettes. Okay, this one, and when you design a block diagram, you use a function palette. Okay, which is this one. When you right click inside that front panel or block diagram panel, you will get these respective names. But there is another menu, another palette which is common to both. Means like it works on both the palette. For example, when you shift and right click anywhere on block diagram or front panel, you will see this kind of palette. It is called tools palette. Okay? Shift, press the shift and press the right click. You can do it now. Okay, you see tool palettes. This is tool palettes. Okay. Now,
If I accidentally close that window, then how can I open
which window you close?
the function?
Function. You can right click again.
Click. Oh yeah.
Yeah. So that is called floating palette. Okay. So it will be available until you have the block diagram open. So until block diagram is there, you right click, you will see function palette. When you right click on front panel, you will see control palette. Okay. But when you press a shift key and then right click, you will see tools palette. And this is available for both the diagrams, like front panel as well as on block diagrams. Okay. So this is used for different purposes. I will not give details about what is the uses. You can see into that books. Okay. So in book, everything is detailed there. Okay, so there are three types of palettes. One is called function palette, one is control palette, and one is tools palette. Okay, tools palette is available for front panel and block diagrams, but the control palette is only available for front panel, and function palette is only available for block diagrams. Okay. Yeah. So, and there is one more function is available. It is called context help. Okay, context help. It gives you very good information or brief information about what you're trying to do. For example, I make one entry on my front panel and two entries on my front panel. For example, here you see the enter value 1 and enter value 2. Okay, so I have different types of data here. Means, for example, if I put my mouse arrow here, I see its context help. Okay, so you see it is kind of integer value. Okay, but when I put my mouse cursor on the another value, you see this is a decimal value. Okay, you can see from like 64 bit real value. So this, even they are looking same, but behind that there is something different. Okay, so this help is very useful to know what's going on in your front panel or on your block diagram. Okay, so it is very useful for new people like us. Like when you try to learn, this will give you a brief idea what you are trying to do. Okay, so now you can see this context help on your screen or no? No, right? On your front panel, you see this context help or no? So to start that, you have to go to the help here, click on help here. Okay, and you see first thing is context help, right?
Yes.
Yeah, you click on that. There will be a small window. Okay, so wherever your mouse goes, it will give you little bit information about that particular thing. Okay. So here I show you some example of what is called front panel. Okay. Yes.
Okay.
Yeah. So you just now see, and when I give you this recorded clip, you try to do it. Okay. Yes.
Okay.
So I designed one section to VI. Okay, and this is like this one. There are like different kinds of controls on your front panels. Okay, we will try to do this on our LabVIEW thing. Okay, I will show you how to do that also. So there is a one entry for number, there is a one for boolean. Boolean data, true, false. Yeah.
Yes.
So this is a one kind of boolean data, and this is a string data, and this is file data, file path or something like that. And this is controls, means like you enter the data, means like you input some data, okay? And this is called output indicators, means like here you cannot enter data, but here you just read the data, okay? Means here you just see what is data coming from the program. It is called indicators, okay? This is indicators, graphs, LEDs, and other things. So this is Boolean data for control, and this is Boolean data for indicator. Okay. This is string data for control, means input, and this is string data as an indicator where you output your data. Okay. And this is the same. And this is for some path value to enter, and here path value to see. It's like if you see something on your screen on your front panel, it is indicator where you cannot enter the values. Okay. And this is the controls where you try to enter the data for the programs. Knob is a special kind of control, okay, where you can try to rotate these to set some value, okay. And meter is its indicator, means if you set some value here, this value will change, okay. So this is connect. And graph is another form of indicator. So if you have collected some data and you want to put it on a graph, it will act as an indicator. So it will not need to you enter any data, but it will just show you how is your data. So it's called indicator. Okay. On this slide, I am trying to show you what are the controls and what are the indicators. Okay. On front panel, and I will show you the same things inside the block diagrams also. Okay. So you see here are these are the controls and indicators, okay. But there is one more thing is there, means like for example, I put this value, okay. This is called enter value. This is information to the user. Like if I put only this thing and nothing said, then whoever use that program will not know what is that for them. So I said it here. So enter some value, okay. That means like user will know that okay, I have to enter some value, and now it is indicator, so I don't need to enter anything here, right? So only I will get output at this place. So I enter value and its output is here, right? So this is, I'm just giving example for that. Because here you enter, but here you just read it, okay? This is output of program, so it's not input. So to show this user that it is not input, it is only output, you mention something here. It is called information for the users, okay? So there are three things on front panel. One is control, okay? These are the controls. Another thing is output, it is called indicators. And third one is some information to the user, like enter some values or select or enter some name or select the file path. These are the information for the user, okay? So we got to know that like on front panel, there are three kinds of information available. One is controls, one is indicator, and one is some information to the users, okay? And now the same thing I see in the, okay? Whatever on the front panel was there, the same things are here. You see, I put enter value, okay? This one. And this is output value. You see the difference between these two. Yes? What differences you see here?
The color.
Yeah, color wise, the color is the same, okay? The color is same. Orange.
The input one is darker than the.
Yeah, yes. So the controls have like this one, darker or thicker borders, but the output will be having thin borders, okay? So this is one kind of indicator. First, another thing is that you see the arrow is here on the right side, right? On the right side. So right side is going out, okay? And left side is coming in. Okay, so this means like a user has to enter some data here, and this is to read the data. Okay, so one is going out and one is coming in. So we always keep in mind that left to right, this data is going in, and from right, is data is going out. Okay, so if I try to connect this wire to here, it's not possible. Means not for example this is called some numbers value. Okay, this is string value. Okay, string means some text. Okay, yeah. So if I try to connect this point to this point, it will be error because numbers are different and text is different. Okay, so you have to have this color coding in your minds. Numbers are connected to numbers, or text is connected to the text, or some knob. This is same, right? This color and this color is same. So you can connect this to here or this to here. So there is no problem. So if the lines are same color, you can connect together. So that's why it is called graphical representation. You don't need to think what kind of number is this. You see color and you can connect. Okay? So don't need to think a lot about that. What is there and what is not there. Okay. So you see. So as I mentioned earlier, there are like terminals, nodes, and wires. Okay. So you see these are the wires, different wires. Okay. And terminals are terminals, you see, means whatever we put on front panel like controls or indicators, it will be put directly on block diagram automatically by LabVIEW. Okay, as a terminal. Why we call it a terminal? Because the data is ended here. It's like data is started here or data is stopped here. Okay, so that's why we call it as a terminal, because data either starts or stops. So these are the terminals. Okay, these are the terminals, and this is the wire where data try to transfer from input to output. Okay, so when we put input and output here, we try to connect using a wire. It is called data wire. Okay, so it transfer the data through wires. Okay, so it is visually you can see like data is will go from here to here. So this is visually possible. Okay, and now I mentioned one more thing. It's called nodes. Okay, so nodes are those things on block diagram which has input and output. Okay, here you see this one. Okay, this block, it is multiplication block. Okay, this is kind of multiplication, means some data is coming from here and we try to multiply by 10. Okay, so it has inputs, okay, and one output, right? Yes. So that block has input and output together, this one particular, this one, right? So this is called nodes. So on the block diagrams, when you right click, you see the function palettes. All those function palettes are a kind of nodes. Okay? Those functions has inputs and outputs. Okay? So that is called nodes. Right? So nodes are those things which has the inputs and outputs. This can be like functions from your function palettes, or another virtual instrument. Like for example, if I design some visual instrument VI, and I want to put it on this my block diagram. Okay, I put it here, and it has input and output. It is called node. Okay, one kind of node, or some express VIs. So what all these three things have this kind of block with input and output. Okay. So I will show you this thing, how to do this, so you know means what I'm trying to say. Okay. Now, yeah, I showed you the wires. Okay, so there are different types of wires also. Okay, so you see the number wires are colored like orange or blue, right? I will send you this file. So okay, I will send you the PPT, and this is same color. Okay, it is same color, right? Orange and blue. This is also orange and blue. But what is difference you see? Thickness wise. Okay? This is small thickness. It is more thicker, and this is a double line. Okay. So this is to indicate like this is one value line. This is one dimensional array. You know array?
Yes.
Yeah. So array is like kind of table, right? So one column of table is called one dimensional array. So if we go to the another table, like it's like many columns table, it is called two-dimensional array because it has columns and rows. So when we connect data of two-dimensional array, we get the lines of double lines. Okay, so it looks like this on your block diagram. Similarly, this Boolean data is singular line, then it's a double line for 1D array, and that is a more thicker for 2D array. Okay, so this is we will know means when we try to do more VIs, we will know this. These are the different things. Okay, string also same means if there is a text one value, it is a thin line, then thicker and more thicker. Okay, so this is the graphical presentation of data. So you don't need to remember what kind of data is there. You just see the lines and you know what kind of data is coming out of your program. Okay, that's why it is called visual program. Okay, yes.
I have a question. What's the difference between the blue and the orange?
Yes, the blue is an integer value. Okay, it's called 1, 2, 3, 4, 5, 6. But the orange is called double value or is called decimal values. Okay, you know decimal values is like 1.5, 1.6, 1.8, 1.9. So those kind of values are only connected by orange line, but integer values like 1, 2, 3, 4, 5, 6, something like that are connected by blue line. Okay, so this is called integer or double, simply in the language of programming. Okay, first what I showed you with my last slide, for example this one, it goes. We try to do this. Okay, this one. Okay? I will design this only on front panel, so you don't need to worry about block diagram. So you do it with me, right? So we will know how to do, right? You see help, and then click this one. Okay, this is context help, right? Or you can click it here to know what is this. So I didn't use the name, so I know what is this, right? Okay, so I right click here. You see right click my control palette. You see my control palette, right?
Yes.
Yeah. So if I don't want to click many times, I just pin it here. So even I click here, it will not go anywhere, right? It will remain here. For example, you see, right click and this pin here. Okay, understand? Yeah, if you want to know, you can ask me. I will tell you. Doubt. Are you seeing my screen now? Okay. Can you able to do it?
Is this a slight difference?
You have different palettes.
The window of the control is different.
Yeah, you see here, I show you. You may be seeing this kind of thing, right? This one? See this?
Yes, but I cannot close the more than. I don't know why.
Which one?
So now you can close the modern or any subsystem there, but I cannot close that. I try to keep the less small arrow, but it doesn't work.
Right click.
Yes.
You can see here.
Maybe I can show you.
Yeah.
Can you?
Yes.
No, just like that. But I don't know why I cannot close this, and also I can only open it like that.
You don't see this kind of thing here. Just click here on empty space. Gone. No, click here. Share your screen. I will do it on your.
I don't know how to.
Oh, okay.
I can share the screen because I'm using the. Can you see?
Yeah. You pin it. This one, you see. What do you call? You see on my. I will show you here. Gone.
Okay, maybe I just turn.
What do you want to say? I don't understand. Means what you want to do is like you want to take it here.
Maybe just continue. Maybe just continue. Yes, just like that. But yeah, just continue.
Yeah. See. For example, all of you. You see. Who gone? Yuki gone. I guess. Yeah. Okay. So if you want to change this to here, okay. So you just pin it here, and okay, then you move it here. Okay.
Cost.
So I'm using NXG style. Okay. So this is NXG style.
Can you explain again how can you do that?
Yes, see here. Right click and this pin one, click on that. Okay. And this you see the two lines at the edge. Okay.
Yeah.
You click on that and you can drag it here down or you can drag it up. Okay. So I'm using NXG style now. Okay.
Okay.
Okay. Okay, so we do like we try to put. I want to use this thing, so I will keep it pinned. Okay, so I don't need to right click many times. So I click on it, I press it this one, and place it here. Okay.
Okay.
Okay, then I will put the Boolean things. Okay, so I go back. This is called Boolean things, right? Then I put control. This is checkbox control. This one I just put it here. You can make it bigger, or then you can put a text one. So you go back here, string control. Okay, and then go back and use another. Okay, so you use right click and put path file control. Okay, I put it here. You can do it.
Yes.
How about she? Can you do?
I'm I actually not open it and just listen it, and I see the view becomes the screen is not shared for me for the operates.
Okay.
Sure.
Okay, so this is control, right? These are all
Okay.
controls. And now I want to put indicators, okay? So I go to numeric and you see here, they are writing here. This is text here, numeric
Yeah.
indicators, okay? So I put it here, right? I create numeric indicator. Then I want to put numeric indicator. It is called Boolean indicator. It is called LED, right? LED. So we put LED here, and then I want to put I want to put a text indicator. Okay, text. It is called string indicator here. So I put it here. Okay, and then I put a path indicator. Okay.
Okay.
Yeah. Can you able to make it, Kong?
Working on it.
Yeah.
Yes. Yes. And now there is a special kind of control. We call it knob control. Okay. So knob is kind of a numerical control. Okay. Right. So the knob means like this. Means you go to numeric one and here. But suppose you don't know where is this knob control, right? If you don't know, then there is one easy way to do this. Like right click and you see here search one. Search button. Write it here knob. N-O-B. See knob. There are knob things. When you click on that, this LabVIEW will show you where it is. Like for example, if I click it, you see here. Okay. Okay. So I know that it is in a numeric one. So I will go here and put this knob. Right. So this is kind of knob. Right. So you see, it is a control. So I can control it like I can increase the value by doing this. Okay. So now I want to put, yes?
Which one did you click? The no?
No. Yeah, you see the numeric one. Numeric.
No.
And there is a knob.
Oh.
Okay. If you don't find like this, you try to search it. Like, right click here and here, go here. You see here. Here, right. It's here. Which kind of knob you want, you just click it and it will show you where it is. No need to remember where it is what, okay? If you know the name, just type and search it, okay? I also don't know. There are many functions which I don't know. I try to find search and I will do it. Okay, so now we put indicator for knob. So there is an indicator for knob is called a meter. Okay, so it is also there in numeric. You see, it is meter. Okay, right. So I put meter here. See, so I am just putting controls right now, only controls, and we will do some program afterwards. Okay, so right now just put a control onto top of this. Okay, you put all these things, meters and indicators.
And
yes?
If I want to move the position of the of that, how can I?
You see here my mouse here. When until it becomes like this arrow. Now you see my mouse. Then I can move.
Arrow.
Yeah. Okay. So it's like automatic. Means you do go to edges, it will change to the arrow of rotation. If you go to the edge, it will become arrow, and when you go to some typing, it will become text. So the mouse changes how you want, where your position is. Okay. So you all you did is now, yes.
Yes, yes.
Then we go to put a one graph. Okay. I put a graph. Okay. You see, I am putting a graph, waveform chart. Okay.
Okay.
Okay, so we finished with our front panel right now. Okay. Yes. Now we go to the block diagram. So how it looks. I did nothing on block diagram right now. Everything what we did is on all on front panel. Okay. So when we open a block diagrams, there will be all terminals automatically placed there. Is it like this?
It's right click and then
View as icon.
didn't find it.
Yes.
View as icon. Yes.
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 So I don't like that big thing, so I remove this always. Okay, so I use it like this. Okay, so this is the same, only smaller things. You can do like this: select all, right click, and view as
Yes.
icon. Okay, if I do this, you see similar like this. Now this. Okay, now if I want to go back to my previous one, I can select all and view as simple. Okay.
Okay.
So, okay, for time being, we use like view as icon. Okay, so I keep it like. So what I showed you, front panel we did. Okay. Now we try to do a block diagram. Yes. So I don't like this scattered around. So what I do, like I select these things. These are all controls. You see arrow on the right side, all controls. So I want to make it in one line. Okay. So how to do that? Like one by one, or you can use this one. You see this function? This is just aligning things. Okay. Once I click it and click on that, it will be like in straight line.
Which one?
Here.
This. I see.
Okay.
Oh, yes, I see.
Yes. So now I want to arrange this as a top. So I do this. Okay. Now this is control and this is indicator. Okay. And now remember, this is just indicator, right? This waveform is indicator, right? Because it has left hand arrow. Okay. So now you try to connect here, like numeric to numeric. You can connect, no problem. Here to here. You was able to do that?
Yes.
Yes. So here to here, okay? Then here to here. But if you try to do like, for example, I have this different control of some green color, and I want to connect it to the text value, okay? I try to do that. What do you see now? This line is not connecting, right? Yeah. And also,
Yes.
if you see here, means at my mouse location, you see this arrow is broken now. This arrow is broken. Okay. So that means that there is some errors in your program. So that's why the arrow is broken. Okay. Did you do that?
Yeah.
If you try to run, it will not run because there is arrow, broken arrow. So you have to correct it before. So how to know what's the problem here? Okay, then here is the more help is coming here, means in context help. If you click or put a mouse arrow here, you will see that you have connected two terminals of different types.
Different time.
Yeah. So this type of source is like file path, and sync means input. Okay. The indicator is of a string type. So you should remember that you should connect the lines of same colors, right? So if it is same color, it is okay. So you can delete it one by one, okay? But you have to delete this and this one, right? But there is one simple trick, like you press Control and B, all the broken lines will disappear, right? Like this.
Control.
Control B. Okay? So now I connect again here to here, here to here, everything I connected. Okay. So now I want to do some called some graph data. Okay. So we don't know how to calculate and everything. We just want to put a sine wave. Okay. If I go to right click but I don't know where is the sine wave function. Okay. So what I will do, right click here and I go to search. I go and search and I write sine. Okay. So sine wave, maybe. I don't know what is that function. Yeah, sine wave. You see, I find it where it is. Okay. So I don't need to search each one by one where to go. So it show me like, yeah, this is sine wave. Okay.
Okay.
Yes. So now I want to have something value here and connect it here. Okay. Right. This value I connect it here with what is this? You see what are the different different terminals of that node in your context help, right? Yes.
Yeah.
So I will connect the sine wave to the graph. Okay. You see?
Yes.
Yes. Now
Yes.
you can see the difference, like this line, the sine line, and this line, the numeric line. You see difference?
Yes.
The top one is a thin line and the sine line is a thick line. Okay. So why this is different?
The the sine wave is the error and the
So it is a value of table. So number of sub values are there. That's why it is a one-dimensional array. Okay. But here we put only one value. That's why it is single line, right? So now I want to put a multiply here. Okay. So I go to the numeric functions. Okay. Go to multiply and add it here. Okay. Now I put one value like called 10 or something. So I put one numeric constant 10. Okay. I multiply, connect one terminal to here, one terminal to the sine data. Okay. And then I want to connect the product of this 10 and the values to the waveform chart. Okay. So I click it here, I delete this line and output I put it here.
what is that 10 is American?
Yeah, you see here, right click, numeric
Yes.
and this double numeric constant.
Oh, okay.
Okay. So the block diagram I show you in the slide, it is done here. Okay, so everything is here. So how do I know that it works? Okay, then we should see it on our front panel, right? So
Yes.
now
Okay,
this
we see.
white background, you see?
Yeah.
Yeah. So this is the control values, right? These are the controls. So we input some data, like for example, 50. I make it on. Okay. So this is on. Now the checkbox is on, and then I put some string. Okay. And I put some path. Okay. Okay. Now what happened? Okay, so these are the indicators, right? These are the indicators. So we don't provide the data, but program calculates and send back this data. Okay, and this knob is control. So we set some value here, and this knob is connected to this value. So this value should change, right? Okay, and we have some sine function here, and it should like make some multiplication, and it will show some data here, right? So to run this program, what we need to do is like click on this one. You see the arrow?
Yeah.
So I will run now, and you see the output here, okay, on the screen, my screen, okay. I will run it, and you should see some kind of output. See,
Yes. Yes.
control is here, output is here, okay. So I checked here, now it is on here on the output. I put string, and the indicator shows the values of string. Okay, the file is here. Now I change the knob, and the data is changed here. Okay, so now you understand, like this is like front panel controls where you input the data, and these are the indicators where you get the data from your program, right? So you did not write anything to indicator, but the program calculates or try to do whatever you want to do, and then send back to these indicators, right? Yes, the sine wave, the
Yeah.
calculation function give me some data, and I multiply the amplitude by 10, so I get amplitude of 10 with this data. So I get a sine wave with amplitude of 10. The sine wave before was 1 amplitude, but when I calculated by multiplying the 10, this becomes 10 amplitude. Now it's clear what I'm trying to show you here.
Can you repeat again?
Yeah. So we see that like we entered something into the controls. Okay? And in the block diagram, we try to connect controls to the indicator. Okay. But we did not write anything into the control indicators. Okay. The program did something background, and it output back to us. So indicators are the output of the program. Okay. So if you want to calculate something, you need to add something to the calculations. So you try to input some data. So we do the controls to input the data. Okay. And when we calculate and we give output, we put indicators. Okay. So that data comes out from the program, and how to show to the user or who is doing program. So we use indicators. So we was controlling this knob, and the meter was showing the output of our program, right? Now there was one function called sine function, and we tried to use that sine function and present that sine function in the form of graph. Okay, so this is done. So how much you did programming here in this lab? Nothing, right? Just put some things and draw some lines, and you are ready with this output. Okay.
I'm still not quite understand the function of the node here.
Node.
Yes.
function of node, it is giving you data of a sine wave. Okay, it calculates the sine of some functions and it gives as a table as a data. So we don't
So
go in details of the sine functions right now. We're trying to know that some data is coming from some programs and we output as a graph using this graph indicator. Okay.
so basically this program is to program to calculate a function 10 times sine x, and the numeric is the input of s.
I put two values, means I have some sine data. Okay, I got the sine data from this function, and the data whatever is coming I multiplied by 10 and then I output into the waveform. Okay, so if you want to know what was the data before multiplying the 10, okay, you have to connect this line to here. Okay, so what I will do now is like just remove this and connect it here. Okay, and just to avoid the error we just connect. Okay, so now this graph will present the data of only sine function, not multiplication, right? What do you see?
It's one.
Yeah, so the sine
But,
function give me some data. Okay, and I put it into indicator as a graph. Yes.
but
Yeah.
it's still not um it's still not convince me what's the function of the node is about 4 points. It's more to get the node, the function of the node.
Function of a node.
Yeah. The node and the meter.
Yeah.
Yeah, if you change the number of the node, then what will
Okay.
happen?
Knob. I was understanding node. Okay. So when you change the knob, just a presentation of the numerical data in the form of knob, nothing different. It is a number. Okay. So I connected this knob to this meter, right? So if I change this value and I run it, it will change the value. Knob
It's
is
just
kind of control.
yeah. That,
Yeah. So it is just to show the people look like instrument, right? Just entering this value 10 or 50 instead of we do this. It is looks good, right? This is graphical language, so we want to show the good things, right? That's why instead of just putting the numbers here, we put this kind of control, right? There are other controls also. For example, this one, you see, this is the same thing, numeric, but it looks like slider. Okay, so this is kind of control to to give the numeric value. Is for example, this is like 0 to 10. If you want to like 0 to 100, you can add it. So you can give value of this much. So this is a different style of showing the numeric control. If I want to like, I want what is the data of this value, I will show you here. So if I change, you see here. Okay. So this is the same and this is the same. This is connected. For example, if I want to put 50 here, I just enter and this arrow is become 50. Okay.
okay.
This is kind of controls for numeric values. So instead of typing numbers, we just drag it like this one. Go high, right? This one, high down. Okay. Yes.
It's just the same as the numeric. So why do we also need this need the numeric?
What? Yeah, you can ask. Yes?
So it's just
Yeah?
it is also the same that input a number.
Yes.
The function is to input a number. Then why do we need to use the uh, numeric
Okay.
the yeah
Yeah. So you are saying why we use this and this to same time,
yes
right?
yes.
Because it looks good, right? It looks good. Oh no.
But if you input two different number um in the node and in the number, and then you will see mistake.
No. This is to have good control. Actually, means you see, this is same. Means this is one type of control and this is one type of control. Okay.
So this is
So
different frames.
and it looks different, but it is the same. Function is the same. So some people like to type. Okay. Some people like to type, and some people like to do this. Okay. So on your instrument, if you have like controlling the knob or entering the number, so which one is better? If you want to accurate, you can control the knob very accurately, finely. Okay. So this is just visualization of your control. So if you want to go with only numeric one, this one, that is also fine. If you want to go with this, it is also fine. It is like how you want to visualize your front panel. It depends on you. Somebody use a gray color, somebody use a green color, somebody use some text value, number value, or somebody use a knobs. So this is just to visualize your inputs, how you want to input.
So these two are controlling the same thing.
No, this is controlling different, this is different.
Okay.
So this is the function of these controls are same. Give input to the program. Okay. So if you want to give input by entering the number or you want to dragging the number, it is depend on you. Means how you want to show your program, right? So for example, if I continuously run this program, for example, there is a one button called continuous run continuously. Okay. So this is running continuously. Okay. You see numbers are changing. Okay, continuously. And if I want to change the number here, I have to like write it here and then again here. But sometimes I prefer this one. You see the meter?
Yes.
Which one looks good? Huh? This looks good, right? Instead of this numeric indicator, it looks good, right? So only that is the function of that. Means which one looks good, we use that. Okay, that's it. So this is the functionality, how you want to show your program, how it will work. So that's it. Okay.
Okay.
Yeah. So you understand what is the front panel and how block diagrams looks like. So how about we go and do some program like I showed you what here. Yeah. Okay. So I stop this. I save it. Okay. So if I save it, I will give a name like save this. You see I have the chapter 2 folder here, so I can save it to that also. So I will just use the section 2. Okay. Okay. And then I close it. We go some real exercise. Okay. So there is one. There are two ways to do programming in a LabVIEW. One is like use already existing template, or do it yourself. Like you do it from blank screen. What we did in last example, like that we do. Okay. So what we try to do now, just you follow with me. Okay. So I will show you how to do that, and you do it because I have to share the screen. I don't know block diagrams and these things. So we will see how it goes. Okay. So first, what we do is this one. Okay. Use existing template means LabVIEW has a lot of functions already as an example. We use that example and we try to modify. Means there is one example called simulate signal. Okay. And we use it to modify for our how we want to use. So do you remember that I mentioned that there are VIs or functions or nodes we use? These blue things we call it as express VIs. Okay, express VIs. So these are the already built function by LabVIEW, and it is can be used for many functions, many applications. So it depends on you, and it makes our work easier. Okay. So this is called express VIs. Okay. So we try to do this. Okay. So I will open the existing VI and then we modify again.
Yeah.
Okay. So now we try to open that simulate signal example. Okay. So what we do is right click on my computer, arrow, and go to the new. Okay. New program, and then we look for from template. You see template, and generate and display simulated. You got it?
Yes.
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 Then okay, click OK. Then it will add to your project right now. Okay? If you see project, this automatically added, right? Right now we open generate and display, and it is added to your project, right?
Yes.
And we you see the block diagram also, and front panel also, right?
Yes.
Yes. So I will show you my block diagram now. You also have it on your screen. Okay.
Yes.
Yes. Yes.
Okay. So now we want to make it like scaling and modulate. Okay. So we have right now this function, and we don't do anything right now. Okay. We just run it. How it looks, we see. Okay.
Yes.
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 Okay, so if I run it now, I will see my sine wave. Okay, you can run also. Yes.
Yes.
So you see the sine wave, right? Now it is sine wave. I want to make it sawtooth wave. Okay, we will change it in our block diagram. Okay. So go to front panel and put a knob control. Okay. You did put a knob. Yes. And we connect this knob to amplitude. Okay. You can do it.
Which now?
Go to front panel, right click, go to numeric and knob. Are you on front panel now?
Yes.
Yeah. Right click now, go to NXG style. Okay. You find or no?
Okay.
Show me your screen.
Is in the numeric
Yes.
or but I don't see the
You can search.
expression. No.
You find.
Which node is this? Is expression node?
No.
Node or there are so many options.
Yeah, just search on control panel. Control
Yes.
palette, okay, not the function palette. Control palette. Go on front panel, right click. Not on block diagram. When you click on or put your arrow on this particular block, in your context help, you will see what kind of inputs are there. You see? Yes, offset, frequency, amplitude, phase, and everything. Okay, so you connect this one to amplitude. Now go to Express VI, Signal VI, and okay, put 10 here. In linear, you put 10. click on simulate signal, double click, and you will see the configure of simulate signal. Okay, use it to make it sawtooth. Here it was sine, you make it sawtooth. Okay, yes,
Yes.
and then click OK. So it will be like, you see now the function is changed to generate sawtooth sine wave, sawtooth wave. Okay, use this signal to apply to here, scaling and mapping. Okay, I put it here, and then we try to put both the signal into the waveform right now. Okay, now there was when we run the program, there was only one sine wave. Now we will have two waves in the same graph. Okay, so we right click and we put signal processing. Yes. Merge signals. Okay, right click, search, merge signal. Okay, merge signal here. You got this?
Yes.
Now this output signal, we connect it to the one point of this, and the sawtooth we connect to this. Okay, and then we go back and delete the other one and we connect it here. Okay, is it done? Okay,
Okay.
yeah. Now go to your front panel and run how it looks. There are two graphs.
No.
Any error?
Yes, it's too bad.
Yeah. So I will show you my screen now.
No, it's still black. Yes.
The straight line you see, right?
Yes, it's not straight line.
So if I increase the amplitude, you see?
Yes.
So this is how we like use the knob here. Means if we want to do real time, we don't want to enter every time, right? You just change the values by just doing this. So this is easy one. Okay.
Okay.
Right. So yes, so we do it from like scratch, from template. And so we use whatever the available example was there, and we modify it and we make some VI so that it can be used as a program for your applications, right? So there are many applications comes in the market. Okay, so for example, there are many instruments comes in market which has LabVIEW examples with itself. Okay, so we use that example and we open in VI LabVIEW and we modify how we want to use that instruments using a LabVIEW. So this is what we do usually. Means we don't do like start from scratch, but we take their examples and we try to modify it for our purpose. Okay. So there is one more example to do it from scratch. So this is from template. Okay, so we start using example from the NI and we modify for our purpose. Okay, then I stop this. Okay? And I close and save it. Okay, so I save it already. We modify everything and we save it here. So this, you remember the chapter folder, so we save it into that. So everything files inside that project will be saved inside that project folder. Okay, so before going to the scratch thing, I will show you this one. Okay, you see my screen?
Yes, see a screen now.
Yeah, so what we did is this, like, right, we use the example and we modified for our purpose, right? So this is called using existing template for our applications. So there is another way of doing is like use it from scratch, like you have nothing on your VI and you start from blank VI, okay? So before going to do that, I will tell you about something what we did, right? So this LabVIEW is works like only when the data is flowing through the LabVIEW. Okay, so it's not like I want to do this thing and that this thing and that this thing. Okay, so this is not depend on what I want to do. So if I want to do by step, I have to specify the steps and I have to like make a sequence of steps so that the LabVIEW will understand that we will do step by step. But here, LabVIEW always use the data flow. Means your next step is decided by how the data is coming to your nodes in your block diagram. Okay. For example, here you see this is a for example of C language. Okay. Here we do calculate. We decide what are the things. Then we give values and we calculate something and we print it. Okay. So this is we do in calculations. But here you see we do the same thing. Like here integer ABC is there, but here we put just blocks on your LabVIEW block diagrams. Okay. So
Okay.
here you see I just put one example here. Okay. So when we use this kind of sequence, this node will never execute until this calculation is done. Okay, so that means we don't decide that this should work before doing this, but this will automatically be done when these two calculations are done and this value is here available here. So this is called data flow. Means until the data is there, the program will not go to the next step. Okay, it will wait for the data, and once the data is there, it goes to the next step. So this is the LabVIEW's core calculation technology. So that every thing which goes with movement of data. So that's why it is called data flow model. Okay, so LabVIEW uses data flow model, not the data is not so important in other. So that is called control flow, where we decide what to control. But here uh, LabVIEW sees that data is there, so it will go to the next step. Okay, and this one, when we are like in text-based or other languages, the operations are done in a specific order, like it's how we put sentences, that way it will occur. But here in data flow model, for example in LabVIEW, when the data is available, the operation will be done. Like means if the values are there, this will be happening right after that. Okay, you do not wait for another things to happen. Data is there, it will execute the next step. It's like that. So this particular model, like control flow model, where we decide what is the sequence should be, it is very sequential. It's like we decide the procedure and it will occur. But here we can do it parallel. For example, I have these two things, here one thing and here one thing. Okay, so you see there is no connection from here to here, right? Here to here. Yes. So what that means, like this division function will not wait for this thing to happen. Okay, as this is data is there already, this is data is already there, because there is no connection here. These two calculations can occur simultaneously. It is called parallel processing. Okay, so this is the LabVIEW's best property, that it can do many things at the same time. But it is not possible in another languages. For example, this control flow model, there is only what we sequentially we give, the sequentially it happens. But in LabVIEW, it does not wait for sequence to happen. All data is there, it will start doing the calculations. Okay, so these two start at the same time. Means for us it is same time, but for computer it will be sequence. But it is possible that two things can start at the same time, nearly same time in LabVIEW. But the other process programming, it is not possible. Like you have to go by step to go to the next step. But in LabVIEW, it's possible to do parallel calculations. Okay. So there are some examples of control flow model. For example, this Visual Basic, C++, C++, Java, other things. They are used control flow model, but the LabVIEW is only LabVIEW. There are some few others, but LabVIEW is more powerful than other things. It is data flow model. So if data is there, the calculation will happen. So if there are two parallel roads without any connection, these two will start working together. It's possible in LabVIEW. Okay. So that's why it's a very powerful language to learn. Okay. So, and yeah, finally, for simple application, we use such a kind of the control flow things. But if you go for simple to more complex and complex, we want to do some parallel calculations, like two things to be calculated at the same time, and then they can compare together. Okay. For that things, this particular language is very useful. Okay. And now we go from scratch. Okay, now we know what kind of data flow is there. So I will show you how to build this to this. Okay, from scratch. We start a new VI and we try to start doing this. Okay, so for output, I don't know what we will need, but we will do this. Okay, so we do a simulate signal. We go to our project explorer. Okay. Yes. So this is a block diagram, right?
Yeah.
Yeah. So we start with the while loop. Okay. This is to repeat the function what we want to do, right? So I'll just, yeah. So we go for like simulate signal. Okay. Or first we go for stop. What do you call while loop. So right click and go functions in programming and go while loop. Can you find it? Yes.
Fine.
You see here, right click, structures, while.
Yes.
So click and drag it corner to corner, you see. Okay.
Yes.
Yeah, so this is a while loop. Okay, so while loop is there, and you see there at the corner there is a one button or some red dot. Okay, so this is a condition terminal, means for while loop to break, you have to give true value to this one. Okay, so what we give is right click here and create a control. Okay. Yes.
Yes.
So you see the stop button is there. So when I stop this, I click this button. On front panel, there will be stop button. You see on your front panel?
Yeah.
Yeah. So when you run this program and click this stop, the program will stop. Okay. Yes. Because this while loop will break, because this condition is true, and that's why this while loop will break. Right. Yes.
Yeah.
Yeah. So now we put simulate signal now. Okay. So how we put? We go right click, we search, and write a simulate signal. Okay, and you see signal analysis.
Yes.
Yes, just drag it here. Yes,
Yeah.
and nothing to change. Okay, just keep it like that and press OK. Okay, so this is already configured, so nothing to do with this. And then we do a sample compression. Okay, similar thing. You go here and search sample compression. You got this,
Yes. Yes.
and just drag it and drop it here. Okay, and yeah, we keep it like 10 and mean. Okay, yes,
Okay.
okay. So now we connect sine to signal. Okay, the sine is connected to here signal, right? Yes,
Yes.
and there is a one more. You see this, I am dragging this bottom here, right?
Yes.
Yeah, so
Yes.
this is called the inputs and outputs for this vi. Okay, this is express vi, and this is already defined by the national instrument or LabVIEW that there are different kinds of things. So here there is one line called enable. You find enable.
Yes.
Yeah. Then go to its arrow and right click and create control.
Okay.
Yes. Now
Yeah.
I show you this icon. Okay. I created control here. So when I will press enable or disable, means on the front panel, this data will be like compressed by factor of 10. Okay. When I disable, data will be not compressed, but data will be as it is. But when I press enable, the data will be compressed. Means right now, if you click on this simulate signal, you see say sample per second is 1000. Okay, just see here. So these are the
Yeah.
samples per seconds are 1000, which is too much. So we don't want to save all the data. Okay, we want to save some same data but little bit less. So we want to compress the data number from 1000 to 100 by 10 times. Okay, that's why we use this sample compression. Okay, so this is what we did. Okay, and now what we want to put is like uh, build a table. Okay, so right click. Okay, this will not happen here. Let's see. Okay, so we will put a merge signal now. Okay, merge signal. Signal. Yes, and then just drag it here. So we have two types of signal now. One with direct signal, okay, and one with mean signal, right?
Right.
Yes. So now, since we are using while loop, okay, so it will run as fast as possible, right? So when we run this program, this will run very faster. Okay, how fast is your PC? That much fast will be the program, but that will affect your other programs how it is working. So to avoid that, what we do always, we use a time delay. Okay, so so that this whatever we application we are building, it will be like slowly, means stepwise it will do in particular times, like for example. So to have some time delay in your execution of program, what we put is like time delay. Okay, so we right click search and time delay now. Okay, you put like this, you see, time delay, and you put 0.250. Okay, yes.
Yes.
Yeah. So what this function will do, like each cycle will be stopped for 250 milliseconds, okay, and wait for 250 milliseconds to pass, and then when it is passed, then it will start the next day. So this way we use very less power of our CPU when this program will run. Okay, so that way we can avoid using extra resources from your PC. Okay? Now we have done this, and now we will have table and indicator and graph. Okay, so I will show you my front panel now to put something on to top of that. Okay?
Yes.
Yes.
I can see.
Yeah, so we put two controls on the screen, right? One was enable disable, right? And one was a stop for while loop, right? So both are here already, right? So now we will put some graph indicator on top on our front panel. So right click, graph indicator, and put waveform graph chart on your screen, on your front panel. Okay.
Okay.
Yeah. So we have 2 points, like one is enable disable and another one is stop button. Okay. Now we will put one more indicator. It is called table. Right. So we go for express table. Okay. So this is a special table. For that you right click on here and don't go to this one. Go to modern. You see.
Yes.
Go to data no, list table and control. Yes.
Yes.
Yes, and then this X table. Okay, so I put it here. I make it small. So what it will do is, like whatever data is presenting on the graph, it will put also as a data numbers on this table. Okay, so we just drag it in here, and then we go back to our block diagram so that we can connect it. Okay.
Okay. Yeah.
Yeah. So this is what we put on block diagram. The table was here. Okay. So put it inside the while loop. Connect back again. You see what kind of line it is now.
It's
Pink color, very thick. Yes.
pink. Yes. Yes.
So it is a two-dimensional array. If you don't find what is that, you just put your arrow here, and this context help will show you what it is. Okay, you see in your context help what it is.
Table to the array
Of strings. Yes. Yeah. So this is helpful for us. Okay. Now what we do, we put this mean value calculated into the table. Okay. So we connect this to here. Okay. Yes.
Yes.
Okay. Now what I want, like I want to use this value to put one indicator for that value. Okay. So what I will do, like I will put one indicator here. So I have to go back to front panel, right? But you can do without going front panel back. For example, you put a numeric constant like this one. Okay, on block diagram. Yes.
Um,
Right click on numeric
yes, number
and
and
double at the bottom.
uh,
Okay.
yeah.
Okay. So, but this is just a number, right? It is indicator. Okay? So, how to change to indicator right now? So, what we do, right click onto that number, and here you see change to indicator. Yes. So, it will change to indicator. Now, this indicator is available on our front panel. Do you see this indicator on front panel?
Yes, yes.
Yes, see? Okay, so this, I will connect to this value, this mean value. So the mean value also will be visible onto that particular indicator, and also it will be recorded inside the table. Okay. Yes. Yeah. So what we do now is already done. Means what we trying to do is finished. Okay. So we will start to run the program now. Okay. So go back to front panel and we see how it works. Right. You run already, right?
Yes, I remember. Yes.
Yes. Okay.
There's nothing in the graph, but the table has a number.
Yes. So yeah, you see, this is like this. If arrow is good, there's no broken arrow. It means your program is okay. If it is broken arrow, then you will have errors. Okay. So we will see that errors also. But now I run here. Okay. So there is no values on chart, right?
Yeah.
Yes. So we stop it and we go back to our block diagram. We find, if you don't find, go to your front panel, okay, and double click on the chart. You will go to the terminal. Yes,
Um,
you find.
yes, 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 yes.
Now you connect this merge signal together to the waveform chart, right?
Yes.
So you see, we did everything okay. Program was no error, but we did not connect the wire, and we could not get the data to see, right? So even the program is okay, that doesn't mean that you have completed your all steps, right? So you have to be careful with these things. And now you go back to your start. Do you see two graphs now?
Yes.
Do you see my screen?
It's
Yes.
very cloudy. Yes, just like that.
So there are two colors you see, red and red and blue. Or what colors are there on your screen?
Mean. Red and blue. Yes.
Yes. Now stop it, okay, and make the x-axis auto x-axis scale. Okay. And here you go to x-axis and right click and select auto scale, okay, and plus this one you you see, then you just drag it. You see there are two waves now.
Yeah.
Red is mean and blue is sine wave. Okay, so start again, then we see. Yes.
Yes.
Now this is like you're stacking the plot, right? You're stacking. Means 0 is fixed and other number is changing, right?
Yes.
Yeah. We stop again, and if you go to the another graph, it will show you like sine wave moving. So how to change the graph is right click, replace graph, and go to the waveform graph.
Yes. Okay.
You did? Yes?
Yes.
Yeah. So now you run this program. How it looks now. Yes?
Yes.
Yeah. Now you see the graph is moving slowly, but x-axis is constant.
But it's a little bit different from you. I already clicked the auto scale S, but it's still very clouded, the graph.
Is it waveform graph
Yes,
or waveform
waveform,
chart?
waveform chat,
Not chart.
waveform chat.
You need
It's
to
different.
change to graph.
Okay.
Yeah.
Waveform graph. Okay, it works now.
Now see. So there are different kind of presentation, and you see there is how you want to see the data. Like if you want to see the data all together, you keep it as a waveform chart, and if you want to see the what is the main features, you use it as a waveform graph. Okay. So here what you see is a mean average calculated for this point, and now you don't see like there are points, but it is line. Okay. So you want to see the points. Where are the points? Actual points. So what we do, left click, common plots, and put this one.
Okay.
Okay, now you play it again, run it again. So you see this here. Looking good, eh?
Yeah.
Yeah, so now there is one more function remains, like enable or disable. If you click that, what happens you see?
The mean signs disappear.
Yeah, so that means that like if I want to calculate the mean, I have the control on that. Like if I enable it, it will start calculating the mean. But if I disable it, it stopped the meaning calculation. Means I have control over how we calculate, how we present the data. See, so from scratch to make it visible and make it more flexible output, we use the LabVIEW from scratch. And how much did you program? How much did you like type it or make a more programming? It's nothing, right? Yes.
Yeah.
So this is beauty of LabVIEW. Means like if you have your data in your what you want to do, you can do it programmatically. You see it on your screen, and you can visualize and you can do it. Right. So I stopped this. So this was the example for us for like doing the LabVIEW program from scratch, means from nothing to make some visible program. So this was the example. So there are many things to discuss about, but if you do more practices, it will happen to you. Means you will know what's going on under there. Okay. So we save it to like another example, and it will occur in your what we call project explorer, that this program is under that particular project, right? So if you now see your so I had like a QA session for all people. So if there are like 10 people and I want to ask questions, nobody says that I have questions, right? So how about create a VI which tells
Where
you that who will ask the question? Okay. So the question was like we make a VI, means it's like for exercise for you. Okay, make a VI where this VI will tell you. This was what I wanted to tell everybody else, that if nobody's asking question, I will ask my VI, LabVIEW VI, that tell me who should answer the question. Okay.
and then that guy should need
Ask the
to
questions. Yes. What I was putting on QA session, this was this VI. Okay. So
okay.
you see my VI here. Yes.
Yes.
Yes. So this VI is there. Okay, so who should ask the question, right? So I run it. This VI is running now, and when I press it, choose, it will tell me who will ask the question. Yes, it's you.
What?
So
It's
you asked me question, right? So you finished with your questions. Now next time when I choose, your name should not be there in that list. Okay. So this is the list, right? This is the list. When I press next time to choose, your name is not here, and name of Sheen is there. So Sheen should ask question. So
so
similarly,
everybody.
when I do this, everybody will ask question one time each time. Okay. Now Vivian will ask questions, and when everybody is finished, I press it again. It will say no more to ask. Okay, no one to ask. So this was like when I thought like everybody will be there. That's why I made it. What was your question? I'm asking you. It's like
Yes, the enter value. So this is not relevant to the graph, to the chat.
yeah.
So what?
On this, we designed this, right?
Yes.
Yes. So the enter value is this one, right?
Mm-hmm.
And the graph is this one, right?
Yes.
So there is no connection here. Yeah.
Yeah, there's no. Yeah, that's my point. There's no connection here. So
Yeah.
why we
This slide I made it like to show you that like to make a waveform chart you need to have some data. Okay. So data was I got from this sine wave function. Okay. And I presented here.
Okay.
This I made it to show you that there is a node which requires input and output. Okay. So this multiplication is kind of node. Okay. It's a
Mm-hmm.
node on your block diagram which takes inputs and gives output. So this is to give example of node. There was nothing calculation inside this. Okay. And
Okay.
so what we did in the next example was what you were asking right now. So here this was the input of numeric, right? This amplitude
Yes.
one, and we use this to control the amplitude of our signal. When I was changing this, the amplitude was increasing, right?
Yes. Yes.
When it was zero, it was no amplitude there because amplitude is zero. So until you connect these two together, there will be no effect on each other. Right? So that's what I was just saying that this is data controlled programming. Until you supply the data, there will be no changes in your output. Yes. So if you want to make this happen, like if you want to control the wave, you have to connect your data to your wave. Okay? So what was our example? Yeah, this one, this one, this one. Yeah, this one. Here we control this output of this by this boolean data, right? When we make enable, the mean was calculating. When we disable, there was no mean value in a graph. So that way we can control, means until you connect these lines. For example, if you see I connect this enable disable here, but it was controlling data in the graph because this connection was done by this line and connected to this waveform. So until you connect these input and output by wire somehow, you cannot relate to those controls and outputs. Okay. I guess I answered your question, right?
Yes. Yes. Yes.
Yes. So anyway, if you do more things with LabVIEW or you try to read the chapter 2, you will get more details what we was doing, right? Because I know you followed me everything, but when you do it yourself by reading the book or you do by your own thinking, like I want to do some VI with this and this, you develop more ideas. You try to search different things and you find more ideas. Okay. So you do this LabVIEW as per the chapters, and there is some like examples to do, then you will know that there are some small things which help you a lot when you do LabVIEW programs. Okay.
Okay.
So I will, yeah, we have finished now. Okay. So you remember this question, right? I showed
Yes.
you how it looks also. So you make one array where there are names of all people, then make one function or your logic, how you can choose one and delete one name from that array and present it as a chosen one. So this is like exercise to do, but I know it is more things are there, but how you develop your logic for this will decide how you program it. Okay, so you try to do it or try to find another examples and do it in LabVIEW, and then we discuss next time when we talk. Okay.